The fundamentals of this video have already been laid down in 2 previous videos. If at any point you feel lost in this video, I encourage you to go back and watch these 2 videos. If I have a function f of x, and I change its input to 2, then what I have to do is remove all my previous inputs of x's and replace them with 2 to get an output of 9. If I have a function g of x, and I change my input to 7 plus h, then I take all my previous inputs of x out and replace them with my new input. If I have a function f of x, and I want to change my input to g of x, then I replace all my previous inputs of x to g of x. Now what if I told you that g of x is equal to 33 plus x? Then you can go and replace all of your previous inputs of g of x, and then replace them with 33 plus x. Essentially what you did here was put one function inside another function. This is called a composite function. Of course, you can always simplify this function after you change the input. There are 2 types of notation that you'll see for composite functions. A more straightforward sentence that reads create a new function h of x by putting g of x inside of f of x, or a more abstract notation that reads create a new function h of x that is f comprised of g, which has an input of x. I'm going to stick with the first notation because it makes a lot more sense to me. The first thing I'm going to do is change my function notation to something more user-friendly. Now I can attack each one of these guys one by one. The last thing we have to do is define the domain of a composite function. Let's say f of x equals 1 over x squared minus 4, and g of x is equal to 1 over x. then f of g is equal to 1 over x minus 4. Normally, all we have to do to find the domain is to see which values of x will break our function. The only extra work you have to do for a composite function is also remove the number that breaks the function which was inputted into our other function. So for this example, we had to figure out what the domain of g of x is as well. Thus, our domain for this composite function is the set of all real numbers with the exception of 0 and 4.